Hello and welcome back to another video with ItsDrDan, and today we're going to be learning how to cyclize ketones and aldehydes with an alcohol group on the same chain. Now when this happens, we'll be making a hemiacetal and a hemiketal, which will then go to a secondary reaction, creating an acetal and a ketal. Now when this happens, there's a very stereotypical thing that we're going to be looking at. This reaction is kind of like when a snake bites its own tail, and when we cyclize these, they form a very specific functional group here. So this is a hemiacetal. Notice how both oxygens are attached to the same carbon, which is a chiral carbon or an anomeric carbon. The way I always like to remember these, it's like a pair of googly eyes attached to the exact same carbon. Now with this one down here, this is a hemiketal. And so what is the key difference? Well, with a hemiacetal, that started as an aldehyde, which has a CHO group, right? An H that's on here. And you can see it like a little tail that's sticking out. Now the hemiketal, this started as a ketone, so you can see the carbons on both sides of it, and it gets split into two oxygens. In this particular video, we're going to go step by step how to do this reaction, and we will break it down so that way you can repeat this in your introductory organic and biochemistry course. I hope that this video helps, and let's look at the process of how to do this. The first thing that we need to do is determine what the size of our cyclic ring is going to be. So typically what you are going to get is a chain that looks like this. So we can see that we have an aldehyde here, where it is a 5-carbon chain with an alcohol somewhere close to the end. So whenever we get a chain like this, the way that we need to do it is we want to start our numbering at the carbonyl. So that's C double bond O. And with this numbering scheme, this is not a way to number it, but we're just trying to see how many different members of our ring are we going to make, being that this is going to make a heterocyclic ring. So one that's going to have an oxygen embedded in it, like with it as an ether. We're going to stop the numbering at the oxygen that is on the alcohol. So like I mentioned before, we're going to start it at the carbonyl, right? So that's going to be number 1. Then we have number 2, 3, 4, 5, and then we're going to stop it right on the alcohol on the oxygen, because that's going to be a member of our new ring once we make it. All right. Let's look at our next step. All right, so our second step, the whole idea here is now that we have this thing numbered, we need to line up the functional groups, because this is what's going to be showing the exact reaction, because we want to create a heterocyclic group. So when this thing lines up, we want to make it so that way the alcohol is on opposite sides of the carbon, and then the oxygen is on opposite sides of the hydrogen. One way for you to think about this is if you go back to electronegativity, intermolecular forces, right? The oxygen is delta minus, hydrogen is delta plus. So minus plus. Same idea down here, right? Minus plus. So we want to line up the parts that are going to be attracted to each other, kind of making a indirect intermolecular force between both of these different bonds, because this is what's going to lead it to the actual reaction. So now let's take a look at trying to cyclize these. So what we will do is we're going to take this, like I mentioned, we're going to take that C double bond O, and we are going to line it up with the oxygen from the other side. And I'm going to try to color code these as we go. So we have CO, and we're going to line it up with OH from our two parts of our group. Now we are going to keep our numbering. So this was number 1, this was number 6. Now the whole idea here is, as we're cyclizing it, we want it to look like a ring structure. So what is a 6-member ring? Well, a 6-member ring looks like a hexagon. So ultimately we want our ring to either have a hexagon or maybe a pentagon is usually the shapes. It's usually 6 or 5 are the typical shapes for this reaction. So let's start it. So we have 1, then it goes down to CH2, which is going to be our second position, then another CH2, which is our third position. So let's number those 2, 3. Then we have CH2, which is 4, and then CH2, which is 5. And then we'll connect. So we want to show how that thing is going to be bending and have the numbering so that way you can follow along and keep track. And as I mentioned before, right, we're going to be showing this interaction that is here between these different groups, because this is where the reaction is going to be taking place between them. Let's go on to the next step. All right, so with this particular step, now that we have our structure that we made earlier, what we're going to be doing is the snake is going to bite its own tail. So meaning that if you think of the ketone as, or the ketone or the aldehyde as the head, right? So we're going to color code that, where it's going to be biting the hydrogen portion. So we're going to break 2 bonds, and then we're going to form 2 bonds as a result. So break 2, form 2. So what we're going to see here is, well, what bonds are we going to break? Well, this is all about how are the functional groups reacting with each other. So we're going to break a part of each functional group. So we have a little red X on one of the bonds in each functional group. So we take out 1 from the double bond, 1 from the alcohol. Now we're going to be making 2 bonds as a result. So if you remember before, I used these green dots, or we're going to be joining at those green dots. So we break 2, form 2. Now in the process, what's going to be happening is the alcohol is going to turn into an ether, and the aldehyde or ketone is going to turn into an alcohol. Now, once this reaction occurs, this is officially your hemiacetal or your hemiketal. So down here, I drew our little bonds that we had on our structure. So remember, we're going to break 2 and we're going to form 2. So let's take this and we're going to move it to the side. So once those break, what we will do is we're going to erase them, and we're going to now make 2 actual bonds where the green dots were. So as you can see here, we have what is now an alcohol and an ether that have formed in the structure after this reaction has taken place, right? Because if you look at the original, we had an aldehyde and then an alcohol. So things have changed. The different groups change in the structure. So this is a cyclic ring shape. We can clean this up a little bit for ourselves too. So if we take this, what are we going to have? Well, we can show that COH, just to kind of label those little functional groups. We can show how the other ether is going to be in the chain as well. And then we can connect every other little bit. And one thing I kind of noticed here is that we were actually missing a hydrogen in all this as well. So there's a little hydrogen tail that kind of got lost in our original structures as we went through. So there should be a hydrogen tail whenever we have a hemiacetal or a hemiketal too. So let's make sure we have that in our final structure, right? So that's how you can tell, which one do we have? So we have our CH2, CH2, and then our CH2, CH2. Or if you want to draw it like a fancy ring, you can. So this is what it would look like, right? Is both as a geometric and a condensed. Okay, so we have our skeletal structure or geometric, and then we have our condensed structure. All right, now what is our next step? Well, this is where we made a hemiacetal. So the same exact reaction would occur if you do a hemiketal. We'll show that in this video as well. I'll do an example of that. So let's take a look at the final step if you want to make this an acetal. Step 4. Hemiacetals and hemiketals are unstable due to the presence of alcohol groups. So the last thing is, so the alcohol that we originally had turned into an ether. That does not react any further. But the alcohol group that is on our ring structure, that is going to react to make an ether. So we're going to have 2 ethers on our final structure. Now, the way this happens is through a condensation reaction. So we're going to remove water by it reacting with another alcohol group to stabilize itself. Now, where is this reaction most common with is when we go into carbohydrates, carbohydrates will do this by making chains of carbohydrates. So making polymers of these different carbohydrates. So when this happens, this is how polysaccharides and disaccharides form, where multiple rings will react with each other. But we're going to do this reaction just with a simple alcohol, like maybe a methanol or an isopropyl. So we're going to be removing this. So in this reaction, we're going to continue this with the addition of a 2-propanol or isopropyl alcohol. So how does this exactly work? Well, we've done on this channel multiple times in the past condensation. So when we do this, we're going to take the other alcohol. So we're going to take our HO, and being that this is isopropyl alcohol, we will put our little isopropyl group like so. And here we'll put it over here as well. So it's CH with CH3, CH3. Now the whole idea with this is you're going to be removing water to condense it down. So when this happens, we're going to be removing H2O. So we can see H2O from this structure, and we're going to be removing all these pieces. Now when this happens, we're going to be taking that off. So let's just remove that like so. We're going to put that to the side. So H2O is a product, and we're going to be connecting our rings together. So now what we're going to be having is like a little antenna that's going to be attached to the top of our different ring structures like so. So this is what we refer to as a acetal, and it's going to be the same type of reaction with a ketal. There'll be another alcohol or potentially another ring group that's going to be used to attach the two pieces together. So this is how we can do these types of reactions. We're going to be doing another example using a ketal or hemiketal this time. So let's go through another example so you can see it done with both types of structures, and I'll go through some tips on how to do it that way as well. With this question, what we will be doing is demonstrating the formation of a hemiketal with 7-hydroxy 3-heptanone, or a ketone with an alcohol. So the very first step that we're going to be doing is we're going to be determining the size of our cyclic group. So the first thing that we did last time is we started our numbering from our carbonyl and going all the way to our alcohol, including the oxygen in our structure. So you can see here that we have 6 different things that are being numbered, and we ended it at the alcohol group, starting at the carbonyl. And one thing you're going to notice that at carbon 1, we're going to have a little arm that's going to be attached to, right? We don't want to lose any carbons throughout here. So keep in mind, there are still 7 carbons on this chain. So we need to make sure that they're all accounted for here. So you can see that we numbered up to 5 for the carbons, but we want to show our hemi group. So now what we're going to be doing with this structure is we want to line up our 2 functional groups to help illustrate how this ring is going to be. Now, this is where one of my tips comes in. So the first thing is when you're lining this up, we have our C double bond O and then our OH just like before. But notice something different, right? This double bond oxygen is not on the end of the chain. So we need to kind of be a little careful here about making sure we include all of our carbons. So we want to, with this one, we want to like kind of break our geometry rules. Let's write the ethyl so that's hanging off of the side, and it's just going to be kind of awkwardly there, but we want to keep track of it. We don't want to lose it. So this is still going to be carbon number 1. This was going to be, our oxygen was number 6. So we are going to start our structure. So we go to 2, 3, 4, 5, and 6. All right, and let's number them so that we can follow all of those little pieces. All right, so now that we have that, we lined up our groups. So what we are going to do now is in step 3, we're going to actually have the reaction occur. So if you remember, we break 2 bonds, we form 2 bonds. So when we zoom in on this guy, we're going to break one of each of these different bonds, and we're going to be making a bond happen between our carbon and our oxygen or hydrogen to make our 2 groups. So when this occurs, we will be making our little hemi group, which will be our final reaction here. So let's erase all of our little numbers. So we're going to be making our ether, breaking our double bond and our original alcohol, and making an alcohol just like this. So this will be your final structure. We can clean it up for ourselves just so that we can see exactly what this thing is going to look like. So we're going to have our 6-member ring, right? And it's going to have an alcohol embedded in, or sorry, an ether embedded in the ring. And this reaction can do another step. So if it was something that if we added another alcohol to it, it could go through and do another step to it. But this one, we're just going to stop for the matter of time, stop at the hemiketal. So this is how a hemiketal is formed. I hope that this video helped showing how the snake can bite its own tail. We're always changing just the functional groups. Notice also here, just to kind of point out that we still have our chiral carbon. So you can see how there's all carbons there. There's no hydrogen hiding. Unlike the hemiacetal one, there's a little hydrogen tail. So you can see that difference. I hope this video helped you. Please use it to the best that you can to help you with homeworks or quizzes or exams. And I look forward to seeing you in future videos. I hope you all have a wonderful day. Please hit that like and subscribe button to keep supporting the channel. And I look forward to seeing you in the future. All right, now I'll see you all later. Bye now.